You're ready to go. Daniel Sauble.
Hello. So just for those who aren't aware, JavaScript is the world's most popular programming language by almost an order of magnitude. It's pretty crazy. And NPM is how most of the world's open source JavaScript is packaged. So the Npm Registry currently has over 1 million packages hosted on it, and it's growing at the rate of about 40% per year. So it's a really big thing. And so even though this talk is about JavaScript, because I work at NPM and it's most relevant to me, the one we're going to talk about today actually applies to a lot of other ecosystems beyond JavaScript, so just kind of keep that in mind. So a little bit about me. I'm currently a product manager at NPM. I've also worked at Puppet and Sonatype. So I've been in this package management, DevOps, automation space for a while. I'm also a grad student at Harvard, where I'm studying software engineering. I'm also the TA at an advanced machine learning class, so I really love data science stuff too. And there's some other stuff about me below. I also like ultramarathons, so if any of you like running too, I'd love to talk about that. So because I'm out of state, I live in Portland, I'm obligated to share some screenshots from my state. So this is the Columbia River Gorge. If you're looking east from Portland, there's this big house right in the middle called the Vista House that sits on a promontory above this huge gorge, which is pretty cool. There's also Crater Lake, which is the deepest lake in the US. And that's also really cool. It's in a giant extinct volcano. And we have a cool waterfall too, called Multnomah Falls. Unfortunately, half of the year, the weather looks like this, so your mileage may vary. So today we're going to talk about a few things. We're going to talk about open source, why it's popular, why it's successful. We're going to talk about software supply chains, which are important because that's how most open source actually makes its way into our applications. And then we're going to compare and contrast old security practices with new security practices and talk about why these new security practices are better. And then we're going to close with a little teaser about something that we're working on at NPM that we'd like to share with all of you. So open source gives me lots of warm fuzzies because it's basically an infinite, inexhaustible supply of free, quality, reusable software. And the reason why open source is successful is because of this idea of the web of trust. The web of trust is this idea where, there is actually a web there, that because all these eyeballs are looking at the code, they're being very aware of bugs and issues that pop up and reacting quickly to solve those problems. So as a model, open source works amazingly well. Where it breaks down is the way that open source gets consumed. Because most people, unless you're living in the 90s and you're putting script tags into your HTML, aren't going to be linking off to random code snippets on the internet. Instead, you're going to be using what's called a package manager. And that's just one piece of this larger supply chain. And so this is where most of these risks come from. This is kind of where we're going to focus our talk on today. And so let's start by talking about the software supply chain. So this is what this looks like for most companies. On the bottom left, you have a developer who's happily writing code. But because they're a smart developer, they're not writing all of the code themselves, and instead they're using open source. In fact, if you write web apps, chances are 97% of that code comes from NPM, which is an astonishingly large number. But for the 3% that you are writing, you're going to be checking that into a source code management tool of your choice. Maybe it's GitHub or GitLab or Bitbucket. So where does the rest of the code come from? This is where packaging comes in. So packaging is really, really important because it provides a way to make code readily usable and extensible by others. So again, if you're a JavaScript developer and you want to use some open source JavaScript, there's a few layers you have to go through. You're going to use a package management tool, which for JavaScript is usually the npm CLI. And that command line tool is going to interact with a package registry. And that package registry contains all of these packages, which themselves are basically encapsulated JavaScript. So all these layers in between are really, really important for open source to be easy to consume. And so again, that registry is where all of these packages are stored, this warehouse. And every ecosystem has typically one or maybe two authoritative sources of all open source for that ecosystem. So if you use Java, that's going to be Maven Central. If you use Python, that's going to be pypy.org. If you use .NET, it's going to be NuGet.org. And JavaScript, of course, it's npmjs.com. But for an enterprise, even though you could just point your command line tool at the registry and go, you probably don't want to do that because the internet is a giant dumpster fire, and those public registries can go down at any time and cause all sorts of mayhem. So what you're going to want to do is have a caching layer. And this is where repository managers come in, because they provide those additional guarantees that what your applications require is going to be there when you need it. And so if you're a developer, again, and you're running npm install on the command line, you might know that the command line caches stuff automatically, right? It's going to put stuff in your node modules. It's going to use its global cache and aggressively ensure that your performance and reliability is as good as it can be. But again, in an enterprise, you typically aren't going to do this. You're going to have a CI/CD system that's going to be purging its cache because it wants to make sure that builds are reproducible, and having a node modules folder that's sitting around can cause problems with that. So again, the repository manager can provide a little bit of can provide those caching benefits without necessarily getting in your way. And then once you've done your build and you've happily merged that proprietary code you've written with the open source, again, you're going to push it up to a repository manager so it's ready for use when you need to deploy it to your environment of choice. And so after you've deployed it, that's kind of the end of your software supply chain journey. So this large surface area creates these security risks. And so let's talk about what some of these risks are. So the first risk is, again, that those registries and repository managers can be compromised. There was a case in 2017 where some operations engineer gained access to Homebrew through some exposed GitHub API tokens in like 30 minutes, which gave them access to all of the Homebrew packages, which wasn't good. And this can happen to any ecosystem, right? And if you have a repository manager, and that repository manager is publicly accessible and maybe has vulnerabilities, then again, it can be a point of failure that an attacker can gain advantage of. A second problem is that social engineering attacks can be used to gain access to your applications via a package that looks legitimate but actually isn't, because like I published to a namespace that looks legitimate but isn't. Or maybe you accidentally published your credentials to GitHub, and an attacker found those and was able to use those to publish malware to that package. A third problem is that malware can be inserted deep into your dependency tree. So there's this old joke about JavaScript that running npm install downloads half the internet. This is more or less true. But the thing is that like all those transitive dependencies are a real problem because they obscure the true surface area of your application. If you have 10 packages in your package.json, you might think, these all look good, but like 3 layers deep, there's some malware that someone's inserted, and that's going to flow downstream and affect your application. So dependency trees are kind of a big problem. And then there's this problem of code drift. So the code that you've checked into your SEM can be subtly different than the code that you've packaged and published to your package manager. And there's nothing that necessarily enforces that these two things are the same. So you might look at GitHub and think things look good, and then someone's managed to compromise your packaging, and you're downloading something that's bad. And a fifth problem is, again, caching kind of can create more problems than it solves sometimes. So if you have a repository manager, the thing about repository managers is they don't really care what's upstream in many cases. So if you're using it to host stuff and you're publishing a package that has the same name and namespace as something upstream, something local in your CI environment, it's going to pull down that cached or hosted thing with the name that is being requested as opposed to the true upstream thing. This was actually a problem that we ran into recently. And finally, there's this larger problem of burnout in the open source community. And maintainers don't want to be maintainers for eternity. Eventually, they get tired of it and want to pass over ownership to somebody else. So when this transfer takes place, a package can go from someone who's a trusted member of the community to someone who isn't. And with Event Stream, what happened was this change of ownership took place, and the new owner decided they wanted to put a Bitcoin miner in there, and so they did. And this causes problems. There's probably a lot more that I haven't even talked about. So if any of you have ideas for ways that the supply chain could be compromised, talk to me after, and I can add slides in here and give you credit. So clearly, security is really important. The problem is that security is often portrayed as being an impediment that gets in the way of developers getting stuff done. And unfortunately, this is often accurate. So security is seen as this thing that slows us down, and in actuality, that's what happens. And so some of the bad security patterns that lead to this are, one, this idea of dedicated security teams. On the surface, this sounds good. Like, there's a team of security people over here, and they, this is their job. They're specialists. We're in good hands. But what ends up happening is that you end up with kind of a split brain where the security team has their goals and their agendas and things they want to do, and the development team has very different goals and agendas and things they want to do, and these two sides don't talk to each other, and when they do, it's really painful, and so it ends up really slowing you down. And then there's like the bad pattern of using security tools that prioritize elimination of risk over innovation. And again, slowing you down might sound good at first glance. Like, it means you're being more careful, more thoughtful, like making sure that stuff goes out is really, really good. But it turns out this is actually the opposite of what reality is. And we'll talk about this in a little bit. A third anti-pattern is kind of an us versus them culture. So if you hear things like a developer saying, to get stuff done, you really have to avoid the security folks and their processes as much as possible. Or vice versa, like those developers are always shipping bad stuff and then not taking responsibility or patching their applications. These sorts of attitudes aren't really helpful. And this is, again, something that you see in counterproductive environments with bad security practices. So the good news is that it doesn't have to be this way, and we'd all be a lot better if it weren't. So what are some of the good patterns that we can introduce instead? So the first pattern is this idea of acceleration. How many of you have read this book? Cool. Yeah, so Accelerate is a book, one of the authors of whom is, of course, Gene Kim, who wrote the Phoenix Project. And I love Accelerate because it actually takes a rigorous scientific look at the attributes of high-performing technology organizations. And so something that they show is that there is a positive correlation between the rate at which you release and the quality of the software you release. So everything else held constant, the more rapidly you release, the better your software is going to get, which is exactly the opposite of what we just talked about, some of those bad practices. There's also this good pattern of shifting left, and we all know about this in the DevOps context, but it also makes a lot of sense in a security context as well. This is another great book, which I really like, which isn't really a DevOps book. It's actually a book about medicine, and the basic idea of the book is that this doctor, Atul Gawande, realized that the vast majority of complications after a surgery are caused by a very small number of things that aren't done before the surgery, like washing your hands. And so by giving a checklist of these things to everyone in the operating room, they were able to decrease the rate of complications by like 80% or something. And this is a very low-tech, easy solution to implement, right? And this applies directly to a lot of domains, but also security. So in this spirit of shifting left, if you give everyone on your developer team a checklist of the things they need to do to make sure that security is improved, it's more likely those things will get done, and your security team won't be super frustrated all the time that no one's listening to them or letting them do their job. But you can actually take this further, right? You can embed security people in your development teams. We've actually done this at NPM recently with some pretty good results, because what it enables you to do is have security people who aren't just consulted, but also write code. And so you can use code as kind of the shared language that a team uses to achieve positive outcomes and work together. And so this turns out to be this great buzzword called DevSecOps. Another good pattern that you see is rather than boiling the oceans and saying we have to do all the security things all at once, you say here's the smallest thing we could do that would have a positive change, and do that, and then pick the next thing, and then do the next thing. And this turns out to be really useful because we've all been on projects that were huge and overscoped and end up really getting nowhere, or you get half the way there and then the project's canceled because you ran out of time. So these small wins are always going to beat those large projects that you never finish. The next good pattern that I want to talk about is automation. And the reason I didn't start with automation is because I think there's a lot you can do with just the culture of your teams and helping people think about this, start to think about this in the right way before you introduce this idea of automating all the things. But the reason why you want to automate is because manual security processes are really slow, and that's because humans are really slow compared to computers when it comes to doing some of these, especially rote tasks. And the attackers aren't doing things manually anymore, so maybe we shouldn't be either. There's lots of really fun toys that attackers have now. There's Shodan.io, which is basically a public database where you can search for vulnerable services on the internet and then compromise them if you want, I guess. There's shhgit.darkport.co.uk, which is a live feed of tokens being published to GitHub for your viewing pleasure. It's great. And then there's this whole big bubble called machine learning. And that's what I'm personally really excited about. There was a paper earlier this year where a security researcher was able to use tweets to predict the severity of software vulnerabilities with 86% accuracy before they were disclosed in one of those public databases. So this is a really powerful tool that is accessible for a lot of us, right? But the good news is that it's not only the attackers that have fun toys, we have fun toys too. So we can use tools to help us do this research and remediation automatically rather than doing it manually. So I've listed just a few of those tools here. These are ones that specifically intersect with JavaScript. There's a lot of others that don't. But this is a great starting point. So if you look kind of midway down the list, you'll see something called Npm Audit. How many of you have used Npm Audit or know what it is? OK, so a fair number of you. Yeah, so Npm Audit is something that Npm released a little over a year ago, which kind of helps with this automation problem. So basically, whenever you run npm install, you're going to get a message telling you how many of those 20,000 transitive dependencies have vulnerabilities. And then if you run npm audit fix, it's going to try and update things to get rid of as many vulnerabilities as it can by doing a patch or a minor version update. So this is a really powerful tool that's just baked into the npm CLI. So this is where I kind of wanted to segue and talk a little bit about something that the NPM team is working on. So we have a fantastic security team. And they're the ones who built that NPM audit feature. But they're also working on something really cool next that we want to release for the community to give you something to play with too. So before I jump into the examples, NPM, as you probably know by now, is kind of in this really unique spot. Because you have all these JavaScript developers who are writing code, and they all have to consume it through this NPM ecosystem. So we have a lot of unique insight into usage patterns around NPM. I think we have over 1 billion downloads a month or something. And also, a lot of people publish to NPM. In fact, everybody does. So again, we have lots of visibility into these publishing patterns. And because we have the security team who's doing all this keeping an eye on the registry and making sure it's secure, they're recording what they're learning and discovering. So we have databases of malware and stuff related to the security and general health and well-being of the NPM ecosystem. So what we're doing with this API is we're making this accessible to the community so that all of you have access to the same data that we do. So one of the things that we're planning to release in this API is this idea of publication info. And because this new API is a GraphQL API, because we're cool, the queries for this is going to look something like this. So you'll have your package version, and you can ask GraphQL or ask the API to tell you who published this version. Was it published from a known Tor endpoint? Did it have two-factor authentication enabled? And the reason we're picking these 3 data points is because each of these can help you determine what risk is implied in a given package version, right? So the username can tell you who published it. So you can triangulate that and see if this person is a trusted member of the community doing good stuff or if they're kind of a weird outlier. The Tor endpoint's interesting because if someone has something to hide, they might not want you to know their true IP address. And so masking that can indicate that there might be something going on here. And then with two-factor authentication, I've mentioned people publishing their tokens a few times. Again, like, if you have two-factor authentication enabled, simply because your token gets exposed doesn't necessarily mean someone's going to be able to take that and compromise your package. So again, having this turned on is a really good signal that there's not quite as much risk inherent in this package. So if you send this query, you get back something that looks like this. And so there's the username, there's the whether it was published via Tor endpoint or whether it had 2FA enabled. The second category of things that we want to release with this API is provide insight into malware. So NPM has the world's largest corpus of malware related to JavaScript. And so with the API, what you'll be able to do is say, given this package, I want to know if this package has any malware payloads associated with it. I want to know if this package has any indicators of compromise related to network or file. And what you'll get back is something like you saw before, where it'll tell you, if a package is malware or not. And I didn't quite have it ready in time for this presentation, but we have a third category of stuff we want to release, which is around this idea of package behavior. So this is a slightly more complicated topic, but at a high level, what this is when you're installing a package, it's useful to know if a package has any strange side effects. So if you install a package and it decides it's going to run a post-install script, that is signal that there's something maybe unexpected going on, and maybe you should have a look. And when you go to require that package in your application, seeing if it makes any calls to some server and phoning home, like that's, again, something that might be totally legitimate and also might totally not be legitimate. And so knowing that a package does that before you go to install it yourself can be really useful information. So again, this is something that we plan to release in this API. So why do an API and not do something fancy and UI based? So one thing is that we have a philosophy that security data should be public, and the reason we have this philosophy is because there are a lot of companies that have their own little private cache of security data that they use as a moat and they use as their edge. And the problem with this is that it makes it really difficult as a user of open source to know what's a false positive, what's a false negative. Like, it really obscures the true landscape of vulnerabilities. And so if you're comparing 4 vendors and they all give you different results from a security scan, you don't really know what to think. And so if all this data were public, then it'd be much easier to compare notes and get a better sense of the state of the ecosystem. And so this is a really important thing that we strongly believe at NPM. The second thing is we really want to enable the community. Like, we have some good ideas for how this data could be used to make NPM better, but we also think that all of you do too. And so by making an API around this, it's no longer something that only we get to use, but something that all of you get to use too. The third thing is this is kind of a data sciencey thing, but these base facts that I've mentioned, these are much less interesting than the inferences you make on top of those. So I could imagine a service built on top of this API that lets you say, what is the percentage likelihood that a given package is malware? And this is something that can be inferred when you have all of these facts being fed to your model via this API. And so this is really just layer 1 of what could be many layers of really interesting work done on top of this data. So by creating an API, again, we enable those sorts of use cases. The other reaon that we're doing this is we're kind of building this for ourselves, right? We have a security team, and our security team is awesome, but they're going to be more awesome when they have tools to help them do their jobs more effectively. Again, doing less stuff manually and more stuff automatically. So an API, again, lets us build our own tooling on top of this that helps us be curators of the registry more effectively. And also, we'll probably use this to enhance the npmjs.com experience. So when you're browsing for packages, being able to see whether something was published with 2FA enabled is a really good thing to know, just in the UI as you're searching. So for any of you who are interested to learn about this when it ships, feel free to submit a form here, or we'll also be publishing stuff on our blog, I'm sure. So keep an eye out if you're interested. So just to summarize, today we talked about why open source is valuable. That web of trust means that we can just have this implicit understanding that that software is higher quality, less likely to have issues, and that issues are going to be resolved quickly. But it also has this caveat that the way that open source software is consumed really needs to be heavily scrutinized, because a lot of that infrastructure doesn't have the same level of oversight that just the code does. So understanding how you use open source in your enterprise is the first step to knowing how to avoid some of these pitfalls. And we also talked about kind of this contrast between old security and new security. Like old security it's slow, it's siloed, it's ineffective, it slows us down. Whereas new security, it improves the quality and productivity of our software and development teams, but it also improves the security of our software. And finally, we provided a sneak preview of this new Security Insights API, and we'd love to get your feedback and thoughts on that. And with that, thank you for your time, and enjoy the rest of the conference.